Hey y'all. Today's lesson is about using the Pythagorean Theorem. And if you have your note-taking guide, you see it is kind of long, but the whole goal of today is to use the Pythagorean Theorem to solve real-world problems. So we're going to be talking a lot about word problems today. We're also going to find the perimeter and area of triangles, the perimeter and area of right triangles. If you've forgotten about how to find the area of a triangle, I will review that. And we're also going to teach you how to find the distance between 2 points on a coordinate plane. So if you had 2 points, the distance between 2 points on a coordinate plane. Now, what does this say? Helpful to draw pictures. Because we're talking about real world problems, we're probably just going to talk about the positive answer when you take a square root of something. We've talked about how square roots have a positive and negative, but if we're talking about real world and we're talking about distances, then it's going to be a positive number. You're not going to see many negative numbers, especially in reference to distances. But they're all going to be centered around the Pythagorean Theorem. So let's get started with some of our examples. Okay. All right. Example 1. A 13-foot ladder is leaning. A 13-foot ladder is leaning against a building. Now, mine is abbreviated. So if you have your building, and then you have a ladder, the ladder is 13 feet. The bottom of the ladder is 5 feet from the building. So here to here is 5 feet. The bottom of the ladder to the building is 5 feet. How high up does the ladder meet the wall? So we're looking for the distance up the wall, the ladder, and the building. So this distance here. So hopefully you see the right triangle that we've created. This is our hypotenuse, and we're missing a leg. So you can either write AX or you can write, X squared or A squared is up to you. Plus 5 squared equals 13 squared. I'm putting it into my Pythagorean theorem. Then I'm going to square everything. Now, I have my squares memorized at least through 15, so I don't have to type anything in a calculator. I subtract 25 from both sides, and I get 144. So that means the ladder is 12 feet high up on the building. Okay? Number 2, Eric is hiking from his campsite to a creek. Now, this one you probably want to draw a picture because I remember this one looking confusing. Eric is hiking from his campsite to a creek. He walks 3.5 miles directly south, 4 miles directly east, and then 1.5 miles directly south again. So part A, draw and label a triangle you can use to find the distance between the campsite to the creek. So Eric walks south, which would be 3.5 miles, and then directly east, 4 miles, and then south again, 1.5. So that doesn't really look like a triangle right now, but if you were to connect, see that dotted line? And if we moved this 1.5 and connected it here, it would look like this. So 3.5 plus 1.5. And you would add those together and you would get 5. And then this was 4. So all I've done is I've combined my south 3.5 and 1.5, and then I have my 4 miles east. So that would be the picture that you would use to find the distance between the campsite and the creek. Part B, find the distance from the campsite to the creek. So I'm going to use the Pythagorean Theorem, and I'm going to plug my legs in because I'm missing my hypotenuse. 25 plus 16. And that is what? 41. So C is about, now you would type in your calculator, and C is about, oh, I didn't type it in my calculator. Oh, sorry, I need my calculator. I have all the work except for square root of 41 is about 6.4 miles. And then the last question is, assume that the ground is flat. How much shorter is it to walk in a straight line than it is to take Eric's route? So if you were to go in a straight line, it would be 6.4 miles. But if you took Eric's route, you would have walked 3.5 plus 4 would have been 7.5 plus 1.5. And so then altogether you would have done 9 miles. That was Eric's route. So we saved about 2.6 miles shorter. 2 miles shorter if you went straight than doing Eric. So Eric went south and then east and then south. But if you just went straight to the creek, it would have been about 2.6 miles shorter. Okay, example 3 and 4. Example 3 and 4. All right, find the value of x. So in example 3, I have a trapezoid, but I've broken it into a rectangle in the middle and then 2 triangles. So we're trying to find this long line. We know that the middle is 10, but what we don't know is we don't know these 2 right here. We can find that out though using using the Pythagorean Theorem. This is my hypotenuse, and this is a leg, so I'm missing a leg. I'll call it A. A squared plus 8 squared equals 10 squared. Now, if you know your Pythagorean triples, then you would already know this. This is going to be a 3, 4, 5, but I'll show you. A squared plus 64 equals 100. A squared equals 36 because I subtracted 64 from both sides, and then the A is going to be 6. So this is 6 and this is 6. But the question says find the value of x. So the value of x, this long line right here, would be x equals 22. X equals 22. Okay? Number 4 is a similar shape, except I didn't draw the rectangle in there for you, but you can. So you can draw right here a line, and we now have a right triangle. Since I know this whole thing is 11 and just this part is 5, then I can use my subtraction, and I know that this is 5 and that's going to be 6, even though it doesn't look equal. It is. Even though it doesn't look right, it is. I also know this is 8, and so I'm missing this hypotenuse. This is my C, but I see it's 6, 8, and I know my Pythagorean triple, 3, 4, 5, so if this is 6 and this is 8, then this has to be 10. If you weren't sure, then you would put it into the Pythagorean theorem, but I know that 6 is multiple of 3, 8 is a multiple of 4, and so this would have to be 10 is a multiple of 5 because it's a Pythagorean triple. Okay? So how to find the value of x. Okay, example 5 and 6. Just moving along here quickly. All right, example 5. Find the length of the diagonal of a square with a perimeter of 24 units. So we have a square, and the perimeter is 24. Now, if the perimeter is 24, every side is the same length, I can divide by 4 to find out that each side is 6. So that's what I needed. But the question asks me for the diagonal. Diagonal is a line that goes from one corner to the other, diagonal across. I have a right triangle, so we're going to use the Pythagorean Theorem. These are legs, and I'm missing my hypotenuse. So 36 plus 36. So C is going to be the square root of 72, which, again, I must have not had my calculator when I did my notes. About 8.5. About 8.5 units. So the diagonal is about 8.5 units. All right, example 6. A triangular section on the map has sides with lengths of 5, 5, and 9. Is this a right triangle? Well, do you remember how to test to see if it's a right triangle? You would plug it into the Pythagorean Theorem. Now, the longest has to be the hypotenuse, so that's going to be our C value. 5 and 5 are A and B. So 5 squared plus 5 squared equals 9 squared. That's the question. 5 squared is 25. 5 squared is 25. So this would be 50. 9 squared is 81. So those do not equal each other. So the answer is no, it's not a right triangle because, and then this is the work. If I asked you to explain why, you would have to show me this is the answer. It does not fit into the Pythagorean theorem. They're not equal. Not that it couldn't be a triangle, but it cannot be a right triangle because it doesn't fit into the Pythagorean theorem. Okay? 7 and 8. All right. Some more words got erased. Number 7. Find the perimeter and the area of a right triangle that has a hypotenuse of length 74 and a leg of 70. Now, draw the picture on your paper because I already have the picture. So draw the picture. We're looking for the perimeter and the area. If you have forgotten, the area is half the base times the height. 1/2 the base times the height. So we're missing this leg right here. That's going to be our first part. We have to find it using the Pythagorean theorem. So a squared plus 70 squared equals 74 squared. Then, whoops, you would square it all. A squared plus 4,900. Let's see, 70. Uh-oh, my calculator's dying. Okay, let's see. I'm going to have to try to use my phone calculator, and I really don't like this. Okay, 74 times 74, 5,476. We subtract 4,900, and we get 576, and the square root of 576. That wasn't right. 576? I don't know how to do the square root on here. 576 square root. 24. Oh, so it's equal. So this would be 24. Okay? Now we can find the perimeter. So you add up all the sides. 24 plus 70 is 94, plus 74, 8. So the perimeter is 168 feet. And the area is 1/2 24 times 70. Half of 24 is 12 times 70. And so the area would be, what is that, 840 feet squared. Area and perimeter. And I got the formula 1/2 base times height because I just I just knew the area of a triangle. Okay. Number 8, let me check the time. Okay. Number 8, find the perimeter and the area find the perimeter of the triangle given the area and one leg. All right, so now we are going to start with the area. And we're going to plug in what we know. So 546 is the area. We know one leg is 84. So one leg of the triangle is 84. That could either be the base or the height. I'm just going to put it in here. And then find the perimeter. So we need to find the missing height before we can find the perimeter. Since this is our formula we need to solve, so half of 84 is 42. We divide by 42 on both sides. So 546 divided by 42 is 13. So that means my height is 13. 84 and 13. Now, we have to find the hypotenuse in order to find the perimeter. We don't know the hypotenuse. So I know I'm going to do the Pythagorean theorem. 89 squared plus 13 squared equals c squared. I have no idea. Oh, no, 84. I have no idea what 84 squared is. 84 times 84. Ooh, 7,056 plus 169 is 7,225. And then I'm going to take the square root, and it's 85. This is a lot. So 85 is my hypotenuse. So let me just review. Let me recap. I used the area to solve for the height. Once I found the height, I knew the base and the height of a right triangle. And then I use the Pythagorean Theorem to find the missing third side. Now I can add them all up. I'm going to add up 84 plus 13 plus 85. And my perimeter, my final answer, my perimeter is 182 centimeters. All right, now that one's tough. That one's tough, and you're going to see another one just like it. When it gives you the area and a leg, you have to solve for the missing leg, use the Pythagorean Theorem, and then find the perimeter. Okay, we have one more. Example 9. And I think your notes have a coordinate plane on them. Okay, good, they do. All right, so if you ever have a coordinate plane that says find the distance, well, if it's diagonal, you can't just count up because it goes through the little squares. So here's how you do this. We're going to draw a right triangle. I'm going to go down, and then I'm going to go over, and I'm going to create myself a right triangle. I can count this way. This went down 1, 2, 3, 4, 5. And then I can go over 1, 2, 3, 4, 5. And I got that just by counting down how many went down, and then from here over how many went over. And again, we're only going to use positives because we're doing distances. Since I have 2 legs, now I can put it in the Pythagorean Theorem. 5 squared plus 5 squared equals c squared. 25 plus 25. So 50 equals c squared. Now 50 is not a perfect square, so it's going to be rounded. It's going to be 7 point something. So the square root of 50 is 7.07, so about 7.1. That's the distance between points on a coordinate plane. You're going to draw a right triangle, you're going to find the legs, and then you use the Pythagorean Theorem. Okay, I know this was fast and I know this was a lot, but we will practice all of this in class.